everyone, this is the review for topic 4 test. This is for algebra 1, as you can see right here. All right, we're going to do a couple of the problems from each type for each set of problems, I guess we could say. So here we're going to work on number 2. Josiah mines moonstone at a constant rate each minute. The table shows the amounts of moonstone in pounds that Josiah mines for various amounts of time. All right, so here's the time right here, 2.5 minutes. He has gathered a lot of moonstone, 27.5 pounds, quite a bit. It's really efficient. And it says right here, write a function that models a table of values. Define your variables. All right, so the write a function part, we need two things, this many things. We need the slope and the y-intercept, right? So let's find the slope first. So basically the rate of change is, how much is he getting per minute, right? I like to look for ones that are kind of easy to subtract. So I know these have decimals, but they both have 0.5s at the end. So, they'll cancel out, right? So we're going to go 38.5 minus 27.5. I'm going to go bottom to top just so that I don't have to deal with negatives. We're going to go in that same direction on the left-hand side. 3.5 minus 2.5, which is easy right here. It's just 1. And this one is just going to be 11. So our slope is going to be 11 over 1. Remember, it's the y over the x, right? The difference of y, I should say, over the difference of x. So it's going to be 11 over 1, which we know is just 11. The other thing we need to know is the y-intercept, right? And you can do it two ways. You can think of it logically, right? So if I look over here at 6, I know that 6 times 11 is equal to 66, right? And which is my slope, which means that there is no, the y-intercept is 0. But if you want to make a little table, because, maybe on the test you're like, I don't know, I just want to know for sure. So we know that 6 is 66. So then what would 5 be? Well, you just subtract 11 from 66, which would be 55. And then 4, 3, 2, 1, and then 0. So we subtract 11 from 55, and that would be 44. And 44 minus 11, 33. Do you see how we're just going backwards? And 33 minus 11, 22. 22 minus 11, 11. 11 minus 11, 0. Right? And this right here, this is our y-intercept. So when x is equal to 0, this is our y-intercept. Okay, this is what we're looking for. And we did not have that available here, so that's what that is. So our y-intercept is 0, our slope is m. So it says write a function, so we need to figure out what our what our variables are. So what should we put for time? We could put x for time if you want to, but I like t for time, right? Because t for time. And the amount of moonstone, I'm just going to put m for moonstones. All right, so here's a function, so we're going to write it in function notation, so it's m of t. So remember, the amount of moonstone depends on how much time Josiah is spending mining the moonstone, right? So m of t is equal to slope, which is 11, times the time, which is t. Our y-intercept is plus 0. Since it's plus 0, we don't need it, right? It's irrelevant, and we're just going to leave it like that. If you do decide to write it like this, because that makes you feel better, just want to make sure that I know that you know that it's 0, that's fine as well, all right? But we know that 11t plus 0 is just 11t. So, but this is still acceptable. All right, moving on. It says define your variables. So let's do that. What is m of t? That is going to be the amount of moonstone. Honestly, in pounds, you can just, if you look at right here, it's already defined for you, right? It's kind of nice like that. And then t is going to be the, actually, I like to write number of minutes, not just time. Number of minutes. If you want to say number of minutes Josiah spends mining moonstone, we can do that. But number of minutes is fine as well. All right, and it says right here, now B, determine the amount of moonstones in pounds Josiah gets if he mines moonstone for 14.7 minutes. So good thing we have a function, so we know what to do with that. So what are we going to do with the 14.7? That, remember, is the time. So that's our t, right? So we're going to do this. So we're going to use this function. So m of, and instead of t, we're going to put in 14.7. All right, so wherever we see t, we're going to put in 14.7. So it's going to be 11 times what? 14.7. Is that what you said? All right, and then we're going to just multiply that. So we're going to get our calculator, and we're going to multiply 11 times, just kidding, 14.7. And you get 161.7. So m of 14.7 is equal to 161.7. I'm just going to write in here pounds. So you harvest 161.7 pounds of moonstone. If you want to be a little more specific, we say of moonstone. All right, so there's how that goes. Moving on to the next problem, or types of problems, we got number 6 right here. So if you look at number 6, it says rewrite the explicit formulas in slope-intercept form. And just like how we did before, slope-intercept form, remember, is y equals mx plus b. So remember, we have a variable for y and a variable for x. M and b are just regular numbers that we're going to see. So here's our two variables right here. So this is like our y. The n is like our x. All right, so notice first we have our parentheses. So what are we going to do? We're going to distribute. So we're going to distribute this -4 to both of these two terms. All right, I'm going to copy everything else down. Let me do this in different colors here. So an is equal to 10, because we didn't use any of those things. So -4 times n is -4n. Remember, negative and minus, I'm kind of using synonymously. And then -4 times -1. This is where a lot of people go wrong. -4 times -1, which is going to be, let me put this in a little different color here. It's going to be +4. All right. So this one, if you still have this as -1, you did not distribute the -4, which is bad days. You don't want that. Okay, so make sure you're distributing the -4 to both of those two terms. And now once we have that, no more parentheses, and we're just going to combine like terms. So let's do that. So we've got an is equal to, we're going to put this -4 in first, right? Because that's like, remember we said that our n is like our x. So that comes first. And then we're going to combine the 10 plus 4, right? We don't look behind it, we look in front of it. This is a +10 and this is a +4. So this is going to be 10 plus 4, which is 14. And that's it. Done. Yay. All right. Please practice the other ones. Feel free to press pause and practice them. All right, graph the explicit formula. So this is the explicit formula for arithmetic sequences. So let's see what we do with that. Remember that first term right here is the starting. That's the first term. So remember, the x talks about the terms. So that's why you won't see this on the negative side, because you can't have like a -1 term. Like, what's a negative first term? Doesn't work. Right, so here's the first term, and we're going to start at -7. So we're going to go down. Here's -6. There's -8, so -7 must be here in the middle. And then we're going to go up. Let me use orange. So this second part right here, remember, talks about how much it goes up or down. So since it's +3, we're going to go up 3, right? Every time. And not just up 3, but up 3 and over 1, because it's the next term right there. So we go, this is what we call the common difference. All right, so the next term, which is the term 2, is going to be up 3, which is at -4. And then we're going to go, so the third term right here is going to go 1, 2, 3 up for the next term. 1, 2, 3 up for the next term. 1, 2, 3 up for the next term. Right, you just keep on going until you can't go anymore. Sometimes you'll be able to go all the way through to the 6th term. Sometimes you won't be able to, depending on, how much your common difference is. All right. And so like for this one right here, since it's -4, so again, we start at 7 and then go down 4 since it's -4. All right. Please check your answers in the back, as it is all provided for you. Number 13. Let's try these out. So it says evaluate the function f of x is equal to -x plus 5 at each of these values. So here we're giving the value f of -3. Remember, this is just x. So what I'm going to do here is that we're just going to replace anywhere we see an x, we're going to put in -3. It's going to be -4 times, and what are we putting in for x? -3, right? And then we're going to do order of operations. What do we do first? Multiply or add? Remember, when there's no operation there and there's just a parentheses there, that just means multiply. So -4 times -3, which would be positive 12 plus 5, then 12 plus 5 is 17. So f of -3. So if x is equal to -3, y is going to equal 17. Y meaning the answer. And again, I'm going to just reiterate. Remember that f of x is just y. It's another way of saying y. It's the same thing. Same. We're going to try this one more time. Same function. So this one's going to be, instead of -3 this time, we're going to put in 23. So -4 times, and then plus 5. Let me put that in a different color again, so 23. So -4 times 23 is going to be -92, right? So -92 plus 5, which is going to be equal to -87. So f of 23 is equal to -87. Just want to make sure that that was actually equal to 92. There we go. Practice number 14. And then if you look right here, we're going to do 3 of these because, you know, it looks a little smaller in there, so let me make it a little bit bigger. So if you look right here, it says determine whether the table of values represents a linear function. If it is a linear function, then write the equation. So, which means if it's not a linear function, we can't write the equation because it's not linear. Let's look. We're going to look for slope first. That's how we check. Does it have, does it go up by the same amount? So here, this is 2 and 6, and that's going to be from 6 minus 2 is going to be 4. And here, 10 minus 6 is going to be 4. 14 minus 10 is going to be 4. And here, this is going up consistently at the same amount. So the one on the left should be going up by the same amount as well. So if you look on the left-hand side, how much are we going up by? We're going up by 2 every time. Right? 9 minus 7 is 2. 7 minus 5 is 2. 5 minus 3 is 2. Right? So same. So then that means this is a linear function. And let's write the equation. So y equals mx plus b, right? So remember it was y equals mx plus b. Remember the m is the slope. We have been doing this for days. And the b is the y-intercept. Intercept. There we go. And here the slope is going to be 4. Let me write the slope here. So m is equal to 4 over 2. So it's the difference of y over the difference of x, which is equal to 4 divided by 2, just 2. So we know the slope is 2. So we'll go, let me write this down. 2x. That's a 2, okay. And then we want to know what the b is. Remember from problem number 2, we said that the b was going to be what when x is equal to 0, right? So let's think about this. Let's go back. Let's do some reverse thinking here. So 3 minus 2 would give us that 1. And then 2, this would be minus 4, right? 2 minus 4 would be -2. Okay. So let's think about this. We know that if we're going down by 2s, we're going to go down by 4s on the right, right? But what if we go down by 1? Because we would just want to get to 0. So if we're going down by 1s, then that means we're going to go down by 2 over here, right? Because the slope is 2. Remember, it's 2 over 1, if you want to think about it like that. So if we're going down by 1, we're going to go down by 2 over here, which means from -2, we go down by 2, which means we get more negative. It's going to be -4. Oh, you don't believe me. You think it should be 0. Just so that you know. So we're going to go 2 oh, sorry, we're at negative 2. So remember, it's negative 2 minus 2, and that's going to be negative 4. All right? And again, if you have the number line, that's negative 2. If we're going to go to the left 2, 1, 2, remember what's that going to be? Because remember, our 0 is here. Negative 3, negative 4. So we end up at negative 4. See what I'm saying? So our y-intercept is, let me make the y-intercept green. So that's our y-intercept, so that's going to be at negative 4. Boom. Just like that. All right? So that's our equation. Y is equal to 2x minus 4. Let's try number 16. If you take a look at these, 3 to 6, that's going to be 3. And 12 minus 6 is 6. Now, you notice that they're different already. Doesn't mean we should just stop right there. We're going to continue because we don't know what's going on the left because we didn't take a look at it yet, right? And then 18 minus 12, which is going to be 6. All right, if only that were 6, right? Let's take a look on the left. So these are different, so I'm expecting some difference here between the first 2 and the second 2. All right, so 3 minus 1 is 2. 5 minus 3, ooh, that's 2 as well. I can just stop right here, but I'm just going to continue. 7 minus 5 is 2. Notice the x's are going up by the same amounts, but on the y's they are not, right? Which means we don't have the same slope. Because like between the first 2 points, that's going to be a slope of 3 over 2. 3 over 2. Second one's going to be 6 over 2. See? Different. Not the same, right? So we just say not a linear function. And then we're done. Happy days. All right. I do expect to see work like this and not just you writing not a linear function. I want to see some sort of work. If you just stopped right here, that would have been fine, but you would need to check in case these were the same. Here, let's try this one more time. Ooh, we're going down. So 4 minus 6 is going to be negative 2. 2 minus 4 is negative 2. 0 minus 2 is negative 2. Ooh, all the same. So if these are going up by the same amounts or down by the same amounts, it would be good too. Okay. Negative 3 minus a negative 6 is a lot of negatives going on, right? But if I think logically, go negative 6, how much do I'm going up, right? How much am I going up? I'm going up by 3, right? I'm getting 3 more positive. And then so from negative 3 to 0, I'm going up by 3. And 0 to 3, well, that's a little easier. I'm going up by 3. So now notice my y differences are all the same, and my x differences are all the same, which means, yeah, we have a linear function. Happy days. All right, so what's my slope going to be? It's the difference of y over the difference of x. My difference of y is negative 2. My difference of x is 3. All right, I cannot simplify this anymore, so this is just my slope. And oh, look what we have. The y-intercept, we don't have to calculate it out. Happy days, right? Already there given for us. So y is equal to negative 2/3 x, and then plus 2. There's our equation. No other calculations needed because the x-intercept is already given for us. All right, we're going to talk about Terrence now. So Terrence received a gift card for 80 bucks from his friends on his birthday, so he can pay for an online subscription that is $5 a month. That's not terrible, I suppose. Write a function that describes the dollar amount D on the gift card after T months. So they give us the variables D and T. So D is the amount of money on that gift card, and T is the number of months. It says, oh wait, we're writing a function. Duh, I'm sorry. So let's write that function. We do know that it's $5 a month, and whenever we see something like a month, per month, each month, or one of those kind of words, this is talking about our slope, our rate of change, because how much is it changing per month? I guess yeah. And then our y-intercept, so this is what we start with, like our initial amount, right? So that's our y-intercept. So the y-int. So let's write this out. So our function is going to be, so it's going to be d of t is equal to our slope, which is 5, times the time, plus the 80. Ooh, one thing to note. Remember, we're taking money out of this gift card, which means that the slope should actually be negative. Okay, so this should be, so m is equal to -5. Because we're not paying into the $80, right? Because it's a gift card, and we're using the gift card to take money out, right? This may make a little more sense if we look at the graph here. So we're saying that the x-axis is the time, and this is going to be in months, because each month he's paying out, right, from the gift card. And this is right here. He says that D is the amount of money in the gift card, on the gift card right here, right? So I'm going to just say balance on gift card. And yes, we're in dollars. Okay, we are not doing other monies, not like euros or yen or won or anything like that. There we go. So if this is the balance of the gift card, we start out where? At 80, right? The next month, we would start out, oh, there's a 2 right there, by the way. You can't really see it very well, but on your paper, you should be able to see that. I don't think something happened with the printing. It was weird. But anyways, so the next month, how much would we have on that balance? 75, right? So it would be next month. So we're going by 2s. So there's a 2 there, by the way. So 1 would be right here, and it'd be at 75, right? $5 you paid. So the next month, it would be $5 less than that. So that would be at 70. Do you see what I'm saying? So we're taking out money. So that's why that's a -5. What I like to do is I like to think, well, how long is it going to take me to have no money left? Or not me, I suppose Terrence, right? So if we have 80 bucks, so let's just figure this out. So let's say, remember, this was going to be our balance, right? So we want to have no money. How long is that going to take? We want to know. So we're trying to figure out the time. So it's going to be -5t plus 80. All right, and then so I'm going to just add 5t on both sides. Why 5t? Because -5t plus 5t is what? 0. Right, so I'm going to go 5t. Now I don't have to deal with negatives. Happy days. So a lot of you guys in your brains are going to logically figure this one out. Because if you know that the balance of the card is 80 bucks, right? And we know that it's $5 each month, right? So then how do we figure that out? It's 5 times something is going to give us that 80 bucks, right? Some number of months. So instead of trying to figure out, okay, 5 times 5, 5 times 6, 5 times 7, instead of spamming numbers, we just go, well, what's the inverse of 5? Multiplying by 5, dividing by 5, right? And so we're going to go, well, t is equal to 80 divided by 5. Well, what's 80 divided by 5? 80 divided by 5. 16. See? That's how we do that. All right. So we know that it's going to be in 16 months. It's going to have no money. So that's actually our x-intercept. So right here at 16 months, personally for me, what I like to do is find the y-intercept and the x-intercept and then just draw that line. Because we know it's linear, so it's not going to change in between. It's not going to be like a different, like this. I'm not going to draw an arrow. It's going to start and stop here, and I know that because it's money, and the gift card's not going to have like, oh, 90 bucks on the -1 day, like, or -2 day. That doesn't make any sense. And once you're done with the money, that you're not going to go there. It's not a credit card, so where you can go into debt. You're just done. You can't use that gift card anymore, right? The beauty of gift cards, just like that. So we're going down, again, our slope is -5. So going down 5 over 1, down 5 over 1, just like that. All right, and it says label the x and y intercepts, explain what they mean in context. So here, I'm going to be, let me make this in green. This is my y-intercept. What does that mean? So it'd be like y-intercept. This is 0, 80. That means when he first gets the gift card, when Terrence gets the gift card, it has a balance of 80 bucks, right? At time 0, gift card has 80 bucks in there. So what does the x-intercept mean then? We'll go x-intercept will be blue. So this is the x-intercept. It says label it. We labeled it. And then, so what is the x-intercept? So that's going to be at 16.0. What does that mean? Remember, no money, no money in the bank account or in the gift card. So after how many months? 16 months. The gift card has a balance of $0. Or you can say there is no money in the gift card. You can say that because no money means 0, right? Either way is okay. All right, we did all the things that they asked us to do: graph, right? Label and explain in context, right? We're not just saying that the y-intercept is the starting point. That's not, there's no context in there. You need to put in like what is $80, the gift card balance, things like kind of that, or amount of money on the gift card. That's fine as well. If you can't figure out the words for that. All right, moving on. We will talk about Sandy and Noel. Sandy is already has already practiced baking sourdough bread 8 times. She's baking bread. And she has decided to practice 3 times each week. Noel has already practiced 4 times. Look at that. After 5 weeks, he has practiced a total of 29 times. What does that mean, right? So how many times did he start baking? Well, if he started at 4, right? So if you take out 29 from 4 from 29, that's 25, right? Which means for 5 weeks, it took him 5 weeks to practice 25 times, right? Well, how do you figure out for 1 week? So that slope is going to be 25 over 5, right? Do you see what I'm saying? So that's going to be 5 right there. And if you look very carefully, I know you can't see it very well. Let's see if I can zoom in. I think that's about as zoomed in as I can get. Still not very well, but yeah, so you started, this is 4 right here. That's 8. So we're going to go up to, which means each one we're going up by 2s. So this is 9 right here. So from 4 to 9, do you see? That's 5. 5 and then over 1. See what I'm saying? All right, and it says, this is just a synopsis of what just happened, just reiterating. What is the y-intercept of Sandy's situation? Well, y-intercept, remember, is the beginning. What does she do in the beginning? That's the y-intercept. 8 times, right? So it's going to be 0, 8. That's the y-intercept. And she practiced baking sourdough 8 times. Maybe she first, or she already, let's use the wording that was already given, right? She already practiced baking sourdough 8 times. Well, what about Noel? Remember Noel? Already practiced 4 times, right? Already practiced 4 times here, y-intercept. So y-intercept is going to be 0, 4. And then Noel already practiced baking sourdough 4 times, right? There we go. That was Sandy's situation and Noel's situation. Now it says right here to compare the rate of change, which is the slope of each function in terms of the quantity. So first we need to figure out what's the slope. Let's go. For Sandy. Sandy's going to be slope is 3 times. Remember it says, I told you to look for each, like each week or a day or actually this would be a week, every week, that kind of thing. So 3. So that's going to be 3. And null is going to be slope. Remember we talked about that already? Right here it is 5. So, and it says to compare. So if you just leave it like this, we didn't compare, we're just stating what they are. We didn't make any comparisons. So you need to use words like more than or less than or equal to, greater than, things like that. So I'm going to go with more than. We'll go null practices 2 more times than Sandy. Or I suppose practices baking sourdough 2 more times than Sandy each week. Because not just 2 more times, right? If we didn't have the each week, right? Or maybe 2 more times each week than Sandy. I don't know. I think this sounds better. So yeah, you need to put in each week because it's not 2 more times overall. Is every week he's practicing 2 more times more than Sandy. You see what I'm saying? All right, so that's what we're doing. And explain if the functions are decreasing, increasing, or constant. Well, every time Sandy's practicing more each week, right? So increasing. Null, as you can see visually, increasing. So the functions are increasing because both, we'll call them bakers, both bakers continue to practice each week. There we go. Da-da, done. If it was decreasing, then this would be something like taking away, kind of like with the gift card. Remember, the gift card, that would be decreasing because the amount of money. Let me go before. The amount of money is decreasing as time goes by. See what I'm saying? Constant would be like it goes straight across, like there is no change from week to week. It's just, let's say, pretend for this one, it's just 100, right? It just stays at 100 every week. That would be constant, right? There is no change between them. All right, so we're going to 25. 2 more problems. So given the graph of f of x, graph f of x minus 4. So here's f of x right here. We're just going to subtract 4 from it. Remember, this is transformations. So this is going to just move down 4. So every point on here, subtract 4. So we're going to take, like, say, this point right here. We're going to go 1, 2, 3, 4, 4 down. Take another point like this one right here. 1, 2, 3, 4 down. Right? 1 right here. 1, 2, 3, 4 down. So all these points that are on the line, go 1, 2, 3, 4 down. Do you see how it forms another like straight line? They should be parallel. If they're not parallel, we're doing something wrong. Let me draw this in this color. There we go. Try to be as exact as you can. And notice, look, parallel lines. Slope did not change. Slope should be the same. Only the y-intercept is different. Right? And then you can practice that over here. This is plus 5, so think about what is that going to do to the graph. Here's the original graph. Move it up 5. All right, last problem. Good job, guys. Sticking all the way through. Given the graph of g of x, vertically stretch the graph by a factor of -3. When we're vertically stretching and it's by a factor of -3, we are multiply each point by -3. All right. So it might be easier if we do it with a table. We'll do one of these tables. So here's x, here's g of x, and here's negative 3 times g of x. So remember, x is 0, y is 0. Remember, g of x is just y. And which means when we multiply by negative 3, so if I put negative 3 times 0, which is 0. So that's going to be right there. Doesn't change much. And so let's try the next point right here. So next point, we'll make this the next point. So if x is 1, y is 1. Well, that's good, right? And we're going to multiply g of x. So negative 3 times 1 is equal to negative 3. So this is going to be at negative 3. Right? And so notice the x does not change. Only the y part changes. Next point. So let's go with 2. So if x is 2, that means y is 2. And so negative 3 times 2 is going to equal negative 6. So add this part right here is going to go down to negative 6. So it looks like a line that's going to go this way. Look how it's negative, which makes sense because we're multiplying by a negative number. So our slope is going to be negative. Well, let's try negative 1. Let's go to the negatives. So that's going to be here. So if x is negative 1, y is negative 1. And we're going to multiply negative 3 times negative 1, which is positive 3. So this we're going to go on the positive side of 3 right there. All right, and we'll just do one more. So we'll go negative 2. So if x is negative 2, y is negative 2, which means it's going to be negative 3 times negative 2, which is positive 6. So we're going to go all the way up to positive 6. So again, the x is not changing, it's just the y. If you notice, see that line? Let's try it with this one right here. There we go, drawing that line. Don't forget your arrows, just like that. That's how you multiply by a factor of negative 3. And if you're like, what do I do with all this? This is just the answer, peoples. Okay, just the answer. So, make sure you're checking. It's here and on the back. All right. Good luck. I hope you study well. I will see you later. Bye.